Have you ever looked up at the night sky and wondered what lies beyond the stars? Could there be other worlds out there, waiting to be discovered? What if the answers to some of humanity's greatest questions, the origins of the universe, the possibility of life beyond Earth, and the mysteries of space-time itself, are hidden in the vastness of the cosmos? For centuries we've gazed up in wonder, fascinated by the enormity and mystery of space, yet we've only scratched the surface of what is out there. Each discovery opens up a whole new universe of possibilities, pushing the boundaries of what we thought was possible and challenging everything we know about the nature of reality itself. In this journey through the universe, we'll explore some of the most mind-boggling and awe-inspiring phenomena that exist. From the explosive birth of stars to the formation of galaxies that stretch across millions of light years, the universe is full of unimaginable wonders. We will delve into the dark and mysterious corners of space, such as black holes, where gravity is so strong that not even light can escape, and explore the strange nature of dark matter and dark energy, forces that make up most of the universe, yet remain largely invisible to us. But we won't just stop at the known universe. We will also embark on a quest for alien life, exploring the search for exoplanets in the habitable zone and asking the age-old question, are we truly alone in the universe? As we navigate through this cosmic journey, we'll also look at the technologies and innovations that have allowed us to explore space. From the early days of the space race to today's cutting-edge space missions by NASA, SpaceX, and other international agencies, space exploration has come a long way. The amazing breakthroughs in rocket technology, satellite communication, and space telescopes are giving us unprecedented insights into our universe and allowing us to peer further into space than ever before. Why is space exploration so crucial to humanity? It's not just about looking for new planets or seeking adventure in the unknown. Space exploration allows us to answer some of life's biggest questions about our origins, the fate of the universe, and the potential for life beyond our planet. It helps us better understand our own planet and the forces that shape it. Space research has led to the development of technologies that have revolutionized life on Earth, from advancements in communication, navigation, and medical science to more sustainable solutions for our energy and environmental challenges. The universe is a mirror that reflects not only the mysteries of space, but the future of humankind. The discoveries we make today will shape the world of tomorrow, whether it's the possibility of human colonization on Mars or finding new energy sources beyond Earth. The story of the universe begins with the Big Bang, an event so extraordinary that it reshaped everything we know about space and time. Roughly 13.8 billion years ago, the universe began as an incredibly hot, dense point known as a singularity. This singularity contained all of the mass, energy, and matter that would eventually form everything in the universe. The Big Bang wasn't an explosion in space, but rather an expansion of space itself. In a fraction of a second, the universe expanded from a tiny point to the vast, ever-growing cosmos we observe today. Cosmic background radiation. One of the key pieces of evidence for the Big Bang theory is the discovery of cosmic microwave background radiation. This faint glow, detected in all directions, is a remnant of the early universe, essentially the afterglow of the Big Bang. It provides a snapshot of the universe when it was just 380,000 years old and gives us a glimpse into the conditions that existed at that time. By studying this radiation, scientists can learn about the early universe's temperature, density, and the formation of galaxies. Expansion of the universe. The universe has been expanding ever since the Big Bang. The expansion isn't just the movement of galaxies away from each other, but rather the stretching of space itself. Edwin Hubble's observation that galaxies are moving away from us in all directions was one of the key pieces of evidence for this expansion. The further away a galaxy is, the faster it seems to be receding. This observation led to the formulation of Hubble's law, which provided proof that the universe is expanding. As the universe expanded and cooled, matter began to come together under the force of gravity. Over millions of years, clouds of gas and dust began to collapse, forming the first galaxies and stars. These early galaxies were the seeds of the vast cosmic structures we see today. Role of gravity. Gravity, the fundamental force that attracts matter, played a central role in shaping the universe. In the earliest stages of the universe, tiny fluctuations in the density of matter led to gravitational collapse, eventually forming clumps of gas. These clumps grew larger and denser, eventually igniting nuclear fusion at their cores to become the first stars. Nuclear fusion and star formation. Stars are born when the pressure from gravity forces gas in a star's core to compress, increasing temperature and triggering nuclear fusion. In this process, hydrogen atoms combine to form helium, releasing vast amounts of energy in the form of light and heat. This energy keeps the star stable and allows it to shine for billions of years. First-generation stars, population Ia stars. The first stars, known as population Ia stars, were composed almost entirely of hydrogen and helium, elements formed in the Big Bang. These stars were massive and short-lived, burning through their fuel quickly and exploding as supernova. The supernova spread heavier elements like carbon, oxygen, and iron into the surrounding space, enriching the universe and setting the stage for the formation of later generations of stars, planets, and even life. The early universe was a harsh and hostile place. For the first few 100,000 years after the Big Bang, the universe was filled with a hot, dense soup of particles, including protons, neutrons, and electrons. There were no atoms, no stars, no galaxies, just a chaotic, rapidly expanding sea of particles. The Dark Ages. After the first few minutes of the Big Bang, the universe cooled enough for protons and neutrons to combine and form the first elements, mostly hydrogen and helium. But for the next 300 million years, the universe was essentially dark. This period is referred to as the Cosmic Dark Ages, as there were no stars or galaxies to emit light. During this time, the universe was primarily composed of hydrogen and helium gas. Reionization, the end of the Cosmic Dark Ages, came when the first stars and galaxies began to form. Their energy and light ionized the surrounding hydrogen gas, allowing the universe to transition from an opaque, foggy state to a transparent one. This process, known as reionization, marked the beginning of the universe's current, visible state, where light travels freely through space. As stars formed, so too did the elements that make up the universe today. In the cores of stars, nuclear fusion produces elements heavier than hydrogen and helium, such as carbon, oxygen, and iron. When these stars reach the end of their life cycles, they explode in massive supernova, spreading these elements across the cosmos. Nucleosynthesis in stars. In the cores of stars, fusion reactions convert lighter elements into heavier ones. This process continues until iron is formed, after which no further energy can be produced. When massive stars run out of fuel, they collapse under their own gravity and explode, releasing a burst of energy and scattering elements like carbon, nitrogen, and oxygen into space. The role of supernova. Supernova are the universe's recycling mechanisms, transforming the materials produced in stars into the building blocks for new generations of stars and planets. These explosions create elements that are essential for life as we know it. Without supernova, we wouldn't have elements like gold, silver, or even the carbon that makes up our bodies. The idea of space exploration has fascinated humanity for centuries, but it wasn't until the 20th century that we began to make serious strides in understanding and exploring outer space. The race to explore the unknown began in earnest with the Cold War rivalry between the United States and the Soviet Union, which fueled the space race and set the stage for some of the most historic events in space exploration. The space race. The space race was a period of intense competition between the United States and the Soviet Union that began in the late 1950s and continued through the 1960s. It was a race to achieve major milestones in space exploration, with each side attempting to outdo the other in technological achievements. The Soviet Union fired the first artificial satellite, Sputnik 1, into orbit in 1957, marking the beginning of space exploration. This achievement shocked the world and propelled the US to push for its own space efforts. Sputnik and its impact, Sputnik 1, the world's first artificial satellite, was launched by the Soviet Union on October 4, 1957. This marked the beginning of the modern era of space exploration. This achievement shocked the world and propelled the US to push for its own space efforts. Sputnik and its impact, Sputnik 1, the world's first artificial satellite, was launched by the Soviet Union on October 4, 1957. This marked the beginning of the modern era of space exploration. Its successful launch demonstrated the Soviet Union's technological prowess, and the US government responded by establishing NASA and committing itself to the goal of landing a human on the moon. Sputnik's launch had profound implications, sparking technological, military, and political changes around the world. Neil Armstrong and the moon landing. On July 20, 1969, Neil Armstrong, aboard Apollo 11, became the first human to set foot on the moon. This achievement marked the pinnacle of the space race and was a momentous occasion for all of humanity. Armstrong's famous words, "That's one small step for a man, one giant leap for mankind," captured the significance of the moment. The Apollo program, which eventually sent 12 astronauts to the moon between 1969 and 1972, was a defining chapter in human history. After the moon landings, space exploration didn't slow down. In fact, it expanded rapidly as new technologies allowed us to explore more distant parts of the solar system and beyond. Today, space agencies around the world are engaged in a variety of ambitious missions. While private companies like SpaceX have revolutionized space travel and opened new possibilities for the future. NASA and international space agencies, NASA, the United States Space Agency, continues to lead the charge in scientific space exploration. It has been involved in a wide range of missions, including sending rovers to Mars, launching space telescopes to study distant galaxies, and building the International Space Station, ISS. NASA's Artemis program, which aims to return humans to the moon and eventually send astronauts to Mars, is an example of how space exploration continues to push the boundaries of what's possible. SpaceX and private space travel. In recent years, private companies like SpaceX have drastically changed the landscape of space exploration. Founded by Elon Musk in 2002, SpaceX has revolutionized rocket technology by developing reusable rockets, which significantly reduce the cost of space travel. SpaceX's Falcon 9 rocket and the Dragon capsule have made space transportation more efficient, and the company's Starship project is working toward making human missions to Mars a reality. Mars rovers and robotic exploration. Robotic missions have become the cornerstone of space exploration. The Mars rovers, such as Curiosity, Opportunity, and Perseverance, have provided valuable insights into the Martian surface and its potential to support life. Perseverance, which landed on Mars in 2021, is equipped with advanced technology to search for signs of ancient life and collect samples for future return missions. These rovers are just the beginning of the next phase of space exploration, as scientists continue to send more advanced robots to study other planets and moons. James Webb Space Telescope, JWST. One of the most significant advancements in space exploration is the launch of the James Webb Space Telescope. Deployed in 2021, JWST is designed to look further into the universe than ever before, capturing detailed images of distant galaxies, star formation, and even the atmospheres of exoplanets. Its powerful infrared capabilities allow us to observe objects that are too faint or distant for traditional telescopes. JWST promises to revolutionize our understanding of the universe. Space exploration relies on cutting-edge technologies that allow us to survive in the harsh environment of space and travel across vast distances. Over the decades, advancements in spacecraft design, propulsion systems, and life support technologies have made space travel safer and more efficient. Spacecraft and propulsion systems. Spacecraft are the vehicles that carry astronauts and equipment into space. Over the years, spacecraft like the Space Shuttle, Apollo capsules, and Soyuz spacecraft have undergone significant technological improvements. Modern spacecraft, such as SpaceX's Dragon capsule and NASA's Orion spacecraft, are equipped with advanced life support systems and navigation technology that make space travel more reliable and efficient. Propulsion systems are another crucial component of space travel. Traditional chemical rockets, like those used in the Apollo missions, rely on burning fuel to produce thrust. However, new propulsion systems, such as ion drives and nuclear propulsion, are being developed to allow spacecraft to travel further and faster. These technologies could one day enable missions to the outer planets and even distant stars. Satellite technology. Satellites have become an essential part of space exploration, providing communication, weather monitoring, and GPS services to Earth. They also play a vital role in scientific research, helping scientists study everything from Earth's climate to the structure of distant galaxies. Space-based telescopes, like Hubble and JWST, rely on satellites to capture detailed images of the universe, while Earth-observing satellites provide critical data for understanding our planet's environment. Space stations and life support. The International Space Station, ISS, is one of humanity's greatest achievements in space exploration. The ISS serves as a laboratory where astronauts conduct scientific research in microgravity, testing new technologies and studying how the human body responds to long-duration spaceflight. The station is equipped with life support systems that provide oxygen, water, and food, as well as waste management systems to maintain a livable environment. The ISS has been a proving ground for future space exploration missions, including long-term stays on the Moon and Mars. When we think of space, one of the most mysterious and mind-boggling phenomena that come to mind is the black hole. These cosmic enigmas are not just a figment of science fiction. They are real, and they challenge everything we know about physics, gravity, and the nature of the universe. A black hole is a region in space where the gravitational pull is so strong that nothing, no matter, no light, can escape it. This intense gravity is a result of an immense concentration of mass in a small area, typically formed from the collapse of a massive star at the end of its life. Black holes come in different sizes, ranging from stellar black holes, formed from collapsing stars, to supermassive black holes, which reside at the centers of galaxies. Black holes form when massive stars run out of fuel. As the star's core collapses under its own gravity, it creates a singularity, a point of infinite density with zero volume, surrounded by an event horizon, the point beyond which nothing can escape. The core collapses into this singularity, and the outer layers are ejected as a supernova explosion. The remnant core, if heavy enough, becomes a black hole. The point of no return for a black hole is known as the event horizon. Once something crosses this boundary, it is trapped inside and can never escape. Anything that crosses the event horizon, whether it's a spaceship, a star, or even light itself, cannot break free. As objects fall closer to a black hole, they experience spaghettification, where the gravitational pull stretches and compresses them into long, thin shapes. This happens because the gravitational force is stronger at the closer side of an object than on the farther side. In 2015, scientists made an incredible discovery. They detected gravitational waves, ripples in space-time caused by the collision of two black holes. This discovery confirmed one of Einstein's predictions and opened up a whole new way of studying the universe. By observing black hole mergers and the resulting gravitational waves, scientists can learn more about the properties of black holes and the structure of the universe. Space is largely made up of invisible matter and energy that we can't see directly, yet they are believed to make up around 95% of the universe. These mysterious substances are known as dark matter and dark energy, and they have profound implications for the way we understand the cosmos. Dark matter is an invisible form of matter that doesn't emit light or energy, making it undetectable by traditional telescopes. Despite this, scientists are certain that dark matter exists because of its gravitational effects on visible matter. For instance, galaxies rotate faster than they should based on the visible mass that we can see. The extra gravitational pull needed to explain this motion can only be accounted for by dark matter. Dark matter also helps to explain how galaxies and galaxy clusters form and hold together. Although it doesn't interact with light, dark matter interacts with gravity, and this is how we infer its existence. Dark energy is even more mysterious than dark matter. It is a force that is thought to be responsible for the accelerated expansion of the universe. In the late 1990s, scientists discovered that the universe wasn't just expanding, but the rate of expansion was increasing. This phenomenon was attributed to dark energy, a form of energy that permeates all of space and works in opposition to gravity. Dark energy makes up about 68% of the universe, and although it has been observed through its effects, it remains largely unknown. Understanding dark energy is one of the greatest challenges of modern physics. We can't observe dark matter and dark energy directly, but we can detect their effects on the visible universe. For example, astronomers have observed the way galaxies rotate and how they interact with each other. The presence of dark matter is inferred from these observations. Similarly, the effect of dark energy is seen in the acceleration of the universe's expansion. These phenomena have been measured using tools like the Hubble Space Telescope, the cosmic microwave background radiation, and distant supernova, all of which provide evidence for the existence of these unseen forces. One of the most exciting frontiers in space exploration is the search for life beyond Earth. The discovery of exoplanets, planets that orbit stars outside our solar system, has opened up new possibilities for finding extraterrestrial life. With thousands of exoplanets discovered, scientists are now focused on identifying those that might support life. Exoplanets are planets that orbit stars outside of our solar system. The first exoplanet was discovered in 1992, and since then, astronomers have found thousands more. These planets come in all shapes and sizes, from gas giants like Jupiter to rocky, Earth-like planets. Some exoplanets are located in the habitable zone, the region around a star where conditions might be just right for liquid water to exist, an essential ingredient for life as we know it. Using advanced telescopes like Kepler and TSS, Transiting Exoplanet Survey Satellite, astronomers are searching for exoplanets that have the right conditions to support life. These telescopes detect exoplanets by measuring the dimming of a star's light when a planet passes in front of it, a process called the transit method. Scientists are particularly interested in Earth-like exoplanets, those that are roughly the same size as Earth and orbit in the habitable zone of their parent star. The search for extraterrestrial life has long been guided by the Drake equation, which attempts to estimate the number of advanced civilizations in our galaxy. While the equation is based on several unknown variables, it has provided a framework for thinking about the possibility of alien life. In recent years, the discovery of exoplanets has reignited the search for life beyond Earth, and missions like the James Webb Space Telescope are poised to provide more answers. Scientists are looking for signs of life, such as chemical signatures in the atmosphere of distant planets, that could suggest the presence of microbial life or even more advanced organisms. Space is full of mysteries that continue to baffle scientists and spark our imagination. From black holes to dark matter, exoplanets to the potential for alien life, the universe is far more complex and mysterious than we can fully comprehend. Each new discovery adds another layer to our understanding of the cosmos, but it also opens up new questions that will drive exploration for generations to come. One of the most ambitious goals for the future of space exploration is the colonization of Mars. Over the last few decades, Mars has emerged as the most viable candidate for humanity's next home beyond Earth. With its similarities to Earth, particularly in terms of the length of its day, the presence of water in the form of ice, and its atmosphere, Mars presents an exciting possibility for human settlement. Before humans can colonize Mars, we need to overcome a series of significant challenges. first, we need to develop the technology to get to Mars and back. While rockets like SpaceX's Falcon 9 and Falcon Heavy have already proven capable of launching cargo and crew into space, the journey to Mars, about 6 to 9 months each way, presents a unique set of obstacles. Spacecraft will need to be capable of carrying astronauts and supplies for extended periods, and the crew will need protection from cosmic radiation, which is much stronger in space than on Earth. Elon Musk's SpaceX is at the forefront of the push to make Mars colonization a reality. SpaceX's Starship, which is currently in development, is designed to carry large numbers of passengers and cargo to Mars. Musk's vision is to build a self-sustaining city on Mars, with a goal of having 1 million people living there by 2050. Starship's reusable design and its ability to carry over 100 tons of cargo will be critical to making this mission possible. However, it is not just about transportation. Developing the infrastructure to support life on Mars is crucial, including building habitats, producing food, and creating systems for water and oxygen generation. Living on Mars will not be easy. The Martian atmosphere is thin and lacks the oxygen necessary for human survival. Temperatures on the surface can drop to as low as -125 degrees Celsius, making it impossible for humans to survive without protective suits or habitat structures. Additionally, the lower gravity on Mars, about 38% that of Earth, could have long-term effects on human health. To solve these challenges, scientists are exploring various strategies, including using the resources found on Mars itself, in a concept known as in-situ resource utilization, and developing advanced life support systems that can recycle air, water, and waste. One of the more speculative aspects of Mars colonization is the idea of terraforming the planet. Terraforming involves altering a planet's environment to make it more Earth-like and suitable for human life. On Mars, this could mean thickening the atmosphere, raising the temperature, and creating a stable climate. While terraforming is currently beyond our technological capabilities, it remains a long-term goal for some futurists and researchers. It could take centuries, but if achieved, it would make Mars a true second home for humanity. While Mars is the closest candidate for human colonization, the ultimate goal of space exploration extends far beyond the red planet. Deep space exploration involves missions to other planets, moons, asteroids, and potentially even distant stars. The pursuit of this frontier will push the limits of our technology and our understanding of the universe. The Moon, Earth's nearest neighbor, is a critical stepping stone for future space exploration. NASA's Artemis program aims to return astronauts to the Moon by 2025 and establish a sustainable presence by the 2030s. The lunar surface is seen as a testing ground for technologies that could be used on Mars and beyond. Plans are also in place to mine the Moon for resources, particularly water ice, which could be converted into oxygen and fuel for deeper space missions. The Moon is also an excellent location for future space telescopes and other scientific research due to its lack of atmosphere and light pollution. Asteroids are another promising target for future space exploration. These small rocky bodies contain a wealth of resources, including metals like platinum and gold, as well as water, which could be used to sustain future missions. Mining asteroids could not only provide raw materials for space colonization, but could also revolutionize industries on Earth by supplying scarce resources. Companies like Planetary Resources and Deep Space Industries are already working on technologies to mine asteroids, and while this is still in its early stages, it represents a major opportunity for the future. The ultimate challenge for space explorers is traveling beyond our solar system. While current technology can only take us to nearby planets, stars, and exoplanets are much farther away. The closest star to Earth, Proxima Centauri, is over 4 light-years away. Traveling to such distant destinations would require speeds far beyond what our current spacecraft can achieve. Concepts like nuclear propulsion and even light sails, which could potentially travel at a significant fraction of the speed of light, are being explored to enable interstellar travel. Missions to distant stars could take decades or even centuries, but the possibility of exploring other star systems and perhaps finding new habitable planets is one of the most exciting prospects for the future. Space exploration is not just about discovering new worlds, it also has the potential to transform life on Earth. The technologies developed for space missions often lead to breakthroughs that improve life here on our home planet. Moreover, space exploration can inspire future generations to pursue careers in science, technology, engineering, and mathematics, STEM, driving innovation and progress across all sectors of society. Many of the technologies we take for granted today, such as GPS, weather forecasting, and satellite communication, were developed through space research. Space exploration has also spurred advances in materials science, robotics, and medicine. For example, technologies developed for space missions have been adapted for use in medical devices, such as robotic surgery systems and MRI scanners. Innovations in renewable energy and environmental monitoring have also benefited from space-based research. One of the most profound impacts of space exploration is the way it changes our perspective on Earth. When astronauts look back at our planet from space, they see a small, fragile, and interconnected world, a reminder that we must work together to protect our environment. The famous Earthrise photograph taken during the Apollo 8 mission, showing Earth rising above the Moon's surface, remains one of the most iconic images in human history. It reminds us that our planet is the only home we have, and we must take care of it for future generations. The excitement and wonder of space exploration have inspired countless individuals to pursue careers in science and engineering. As space missions continue to capture the imagination of people around the world, they encourage young minds to explore new ideas and push the boundaries of knowledge. The potential for space exploration to inspire innovation and foster a spirit of collaboration across nations is one of its most significant benefits. The future of space exploration is incredibly bright, with numerous exciting possibilities on the horizon. From the colonization of Mars to the exploration of distant stars, humanity is on the verge of discovering new worlds, technologies, and opportunities. The challenges are immense, but the rewards, both in terms of scientific discovery and practical benefits, are equally great. As we look toward the stars, one thing is clear: the journey has only just begun. As we've explored throughout this journey, space is a vast and mysterious frontier filled with wonders that continue to captivate and inspire humanity. From the explosive birth of the universe in the Big Bang to the mind-bending phenomena of black holes and the endless search for alien life, space is a realm that challenges our understanding of the cosmos and our place within it. We've also seen the remarkable advancements in space exploration technology, from the early missions of the space race to modern-day endeavors like Mars colonization, the Artemis program, and the search for life on exoplanets. These discoveries and missions not only help us uncover the mysteries of space, but also pave the way for future generations to reach even greater heights. The quest to colonize Mars, venture into deep space, and potentially explore other star systems represents humanity's innate desire to explore the unknown and push the boundaries of what is possible. While these endeavors come with tremendous challenges, they also offer the potential for breakthroughs in technology, science, and even in our understanding of life itself. Space exploration may one day unlock the secrets of dark matter, reveal new resources to benefit life on Earth, and provide humanity with a second home in the stars. As we continue to explore the universe, we must remember that every discovery, every step taken into space, brings us closer to understanding not just the cosmos, but ourselves. The drive to explore and expand our knowledge is deeply ingrained in human nature, and it will continue to propel us forward, unlocking new possibilities and inspiring future generations to dream bigger and aim higher. In closing, the mysteries of space are not just fascinating for the questions they pose, they are inspiring for the answers they could one day reveal. Whether it's the next step in Mars colonization, the discovery of alien life, or the exploration of distant stars, one thing is certain: the journey through space is just beginning, and humanity's story in the stars is far from over. As we look to the stars, one question remains: what's out there waiting for us? What do you think is the most exciting discovery about space? Leave your thoughts in the comments below, and don't forget to subscribe for more content on space exploration and the wonders of the universe.